Welcome to my channel. In our session for today, we are going to discuss about the Laplace and transform. When it comes to the Laplace and transform, you need to understand the notations that are being used in the Laplace transform and the first principle formula. So when it comes to the notation being used in the Laplace transform, we need to know that a function f of t the Laplace of a function f of t, this one can be written as the Laplace transform as a function of t, and we have the Laplace transform of a function f can be written as the Laplace transform of a function of f, and we have lastly f bar s or so these are the basic notations of the Laplace transform, whereby sometimes you can find the term s, sometimes the term s is being denoted as p. So the Laplace transform a function f of t can be given as a function of time, which is defined for all positive values of t. So that one means that when it comes to the first principle formula using the Laplace transform, we need to understand that a function f of t, the Laplace transform of a function f of t is equals to an integral with respect to our limits exponential negative st of a function f of t with our integration is with respect to the term of dt, and this one is now the first. Now this one is now our first principle formula. Sometimes this one is being referred to as the linear operator. So also this one you need to understand. This one is our integration with respect to limit and our term of exponential negative st of a function f of t. Now let us get into our first example after understanding the notations of the Laplace and transform. So this is now our first example, whereby you can be told find the Laplace transform of a function f of t is equals to k using the first principle formula. So when it comes to the first principle formula, we understand that the linear operator of a function f of t is equals to integral 0 up to infinity exponential negative st multiplied by a function f of t. Our integration is with respect to dt. So here we are going to find the Laplace transform of a function f of t, whereby the function f of t is equals to k integral with respect to our limits exponential negative st of a function f of t. Our function f of t is equals to k. So here we are going to have k our integration with respect to dt. Now from here, as you can see, our term of k, as you can see here, our differential is with respect to dt, to mean that the term of k is going to be a constant. And when our term of k is a constant, that one means we are going to factor out k integration with respect to our limit exponential negative st with respect to dt. Now from here, we can come and integrate our exponential. And by integration of our exponential, now we are going to have k into exponential negative st all over. When we integrate an exponential, we are going to have negative s with respect to our limits. Now from here, we are going to factor out s because it is not a term of t. And by factoring out our term of s, we are going to have the Laplace transform of a function f of t will be equals to k over negative s into exponential negative st. Now from here, we are going to insert our limits, whereby we are going to start with the upper limit, and we are going to have k over negative s multiplied by exponential negative st. Since we are going to insert our limit where we have our function, our t, we are going to have that we subtract from exponential negative s with respect to the lower limit. Now from here, anything raised to power infinity is equals to 0. That one means we are going to have k over negative s. This one is going to be 0. Subtract from negative s, when you multiply by that, we are going to have 0. Anything raised to power 0 is equals to 1. So here we are going to have a negative of 1. Now from here, we are going to have k multiplied by a negative of 1 over our term of s. When you take this one multiplied by what we have here, our k, we are going to have a positive now k over s. Since the negatives will cancel out. And this is now the Laplace transform of our function k.